Climate change isn't some far-off problem anymore. It's here, and it's happening now. And the only way to really get a handle on what's going on with our planet is to follow the data. So that's exactly what we're going to do today. And our guide for this is Shahin Samadi, a data systems expert who literally built some of the tools NASA and NOAA use to track our climate. So yeah, let's dive right in.
I love this quote from Christiana Figueres because it sets the tone perfectly, right? When you think about a challenge as huge as climate change, it's easy to feel like it's impossible. But she's saying impossible isn't a fact, it's just an attitude. And you know what? Attitudes can change.
All right, so here's our game plan. First, we'll get to know the scientist. Then, we'll look at the hard data, separating fact from fiction. After that, we'll see how this is all stressing out the planet, leading to some serious political tensions. Think water wars. And we'll wrap up with a really big question. Could the Earth actually be alive?
Okay, so first up, a scientist's perspective. But who exactly is Shahin Samadi, and why should we care about his take on all this? Well, let's find out.
So check this out. Samadi wasn't just some guy in a lab looking at spreadsheets. He was collaborating with top scientists at places like NASA and INNOVIM. He literally designed the complex systems that manage and visualize all this climate data. Think about it. He supported critical missions for NASA and NOAA, developing the tech that processes massive amounts of data from satellites and ground stations. He's not just reading the story, he's the one who built the printing press. That gives him a totally unique insider's view of what's happening to our planet.
Right, let's talk about data over doubt. Because, let's be honest, it's so easy to get lost in all of the noise and opinions about climate change. But what we need are facts. So, let's cut through the chatter and look at what the actual evidence is telling us.
Okay, this slide right here gets to the absolute heart of the debate. On one side, you've got the Earth's natural climate cycles. These are driven by things like the Earth's orbit, solar radiation, stuff that happens over millennia. But on the other side, you have this new thing, human-induced warming, driven by greenhouse gases from things like fossil fuels and deforestation. And here's the kicker. The real difference, it's the speed.
And just look at this timeline. 20,000 years ago, we're at the peak of an ice age. Then, over the next 8,000 years or so, things naturally warm up. But then, look at that last little sliver. In just the last century, we see this absolutely insane spike in global temperatures. It's totally unprecedented. And with 2016 and 2020 tied for the hottest years ever recorded, yeah, that trend is not slowing down.
So, all this data, what does it actually mean for us, for the planet? We're moving beyond the charts now and into the real world. We're talking about the tangible, visible consequences of a world that's heating up.
And the impacts? Well, they're everywhere. We're talking more frequent and way more severe hurricanes. We're talking about droughts that just don't end, and record-shattering heat waves. Forest fires are getting worse, both in how often they happen and how intense they are. And it's not just the weather. Animal migrations are getting all messed up, and our oceans are seeing widespread coral bleaching. It's a full-on assault. 18 degrees Fahrenheit. Just let that number sink in for a second. That's how much hotter it was than the seasonal average in places like Greece, Cyprus, and Turkey during the 2024 heat waves. That is not a minor blip. That's a massive, extreme event. And the scary part is, this kind of thing is becoming the new normal all over the globe.
And this is a perfect example of the domino effect in nature. Everything is connected. Take the African wild beast. Their legendary migration routes are thrown into chaos because the rain just isn't predictable anymore. Think about bees and butterflies. Their entire life cycles are getting disrupted, which is a huge problem for all of us. And then you have the coral reefs, which are just getting bleached and killed off by rising ocean temperatures.
And make no mistake, this isn't some isolated problem. We're talking about the Great Barrier Reef, the coast of Florida, the Caribbean Sea. They've all suffered these massive, devastating coral bleaching events. These are the rainforests of the sea, and we're watching them die up in real time. Considering they support about a quarter of all marine life, their collapse would be, well, catastrophic doesn't even begin to cover it.
Okay, so we've seen the stress on our ecosystems. The next logical step? That stress starts to create tension between nations. And it's all centering on our most vital resource, water. Welcome to the era of the coming water wars. And these aren't just hypotheticals. This is happening right now. You've got serious tensions between Turkey, Syria, and Iraq over dams on the Tigris-Euphrates. There's a huge dispute between Ethiopia, Sudan, and Egypt over the Nile. Iran and Afghanistan are in conflict over the Helmand River. And it's not just overseas. Right here in the US, 7 states and Mexico are basically battling it out over the shrinking Colorado River. This is climate change becoming a matter of international security. All right, for our final section, let's zoom way out. Let's get a little philosophical for a moment and ask a really big question. Is the Earth alive?
This idea is known as the Gaia hypothesis. It was put forward by James Lovelock and Lynn Margulis. And the basic idea is that the Earth isn't just a big rock with life on it. Instead, the theory proposes that the Earth itself is a giant, self-regulating organism. The living things, the rocks, the oceans, the atmosphere, they're all interlinked in a way that helps sustain life.
Now, it's a really powerful idea, right? But it's also important to be scientifically clear here. While the Earth does have self-regulating mechanisms, like volcanoes helping to cool the planet, the extreme weather we're seeing today isn't some deliberate response. It's not the Earth fighting back. It's a consequence. It's physics. It's what happens when a system gets pushed way out of balance by our own impact.
And really, that brings us to the most important point of all. If the planet isn't going to just magically fix itself, then that responsibility falls squarely on us. The only way out of this is through global cooperation and a serious shift towards sustainable practices. The ball is in our court.
So I'll leave you with this thought to chew on. Whether you subscribe to the Gaia hypothesis or just see the Earth as a complex physical system, the fundamental question doesn't change. What happens if we push it beyond its breaking point? What does that self-regulation look like when the system finally snaps?